Okay, so what if a machine could see without eyes? What if it could actually feel the world around it, but with invisible light? Well, today we're going to dive into LiDAR. It's this amazing technology that's giving robots a sense that, honestly, might just be better than our own.
So let's just start with something super simple. How do you see the world? I mean, right now, wherever you are, just look around. What are you actually perceiving?
Well, for us, it's all about color, light, and shadow, right? Your brain is just constantly interpreting this symphony of reflected light. You see all these vibrant colors, you get the subtle differences between light and shadow that, defines every shape. It's this passive, beautiful process that's literally guided our evolution. But what about a machine? How does, say, a self-driving car or a delivery drone see that exact same world? Does it see in color and light too? The answer? Nope, not at all. It experiences reality in a way that is just completely alien to us.
And this is the key. This is where it all changes. See, instead of just passively observing reflected light like we do, these machines actively probe the world. They're literally reaching out and touching their surroundings with millions of invisible laser beams. They're building this super precise geometric map of reality. So yeah, it's not seeing. It's more like feeling.
So how is this even possible? How can a machine feel space? Well, the answer lies in some pretty cool and elegant physics. And the technology that makes this incredible sense possible is called LiDAR. Now, you've probably heard that name thrown around, but let's actually break down what it is and how it works. Okay, so LiDAR. It stands for light detection and ranging. But what does that mean? Put simply, it's a way of using pulsed laser light to measure distances with, astonishing precision. And with those measurements, it creates a perfect 3D map of everything around it. So the real magic behind LiDAR is this concept called time of flight. And the best part? It's actually really simple. It all just comes down to timing. It really is a simple four-step process. First, the sensor fires out a little pulse of laser light. That pulse flies out and boom, it hits an object. Then it bounces right back to the sensor. And here's the clever part. The system just calculates the exact distance based on how long that little round trip took. You multiply that time by the speed of light, and bam, you have a perfect measurement. It's so simple, but it's incredibly powerful. Okay, but one single measurement, that's just one tiny dot, right? To build an entire world, the sensor has to do this over and over and over again. We're talking millions of times at a speed that is just mind-boggling. And I'm not exaggerating here, we're not talking hundreds or even thousands of times. A modern LiDAR sensor fires over 1 million laser pulses every single second. Just think about that. It creates this incredibly dense web of measurement points.
So what do you get when you put all those millions of points together? You get this, a point cloud. And it's super important to understand this is not a picture. It's a living, real-time, millimeter-accurate 3D model of the world. It's a digital twin. The machine now knows the exact shape and location of literally everything around it.
All right, so why is this such a game changer? Why not just stick a simple camera on there, right? Cheaper, easier. Well, this is where LiDAR really proves it's a truly superior sensory organ for a machine. This comparison really says it all. You can see how a regular camera just completely struggles in the dark. It gets totally blinded by bright glare. But the LiDAR point cloud, it stays perfectly clear and detailed no matter what. And that's because a camera sees a flat 2D image. LiDAR perceives true, measurable 3D space. Just think about all the problems a camera faces. These things rely on the light that's already there. So they're easily blinded on a dark night. They can get completely washed out by the glare of a bright setting sun. And don't even get me started on heavy rain or fog. Their vision just gets totally obscured. And here is the absolute key advantage. LiDAR creates its own light. It doesn't need the sun. It doesn't need streetlights. It brings its own flashlight, basically. And that's why it performs just as well at midnight as it does at high noon. It gets to see the world on its own terms. So when you have a sensor this powerful, this reliable, it unlocks a future filled with applications that honestly used to just be science fiction. Of course, the most obvious place we see this is in self-driving cars. LiDAR gives them this superhuman awareness.
It's tracking the exact position and the speed of every other car around it. This allows them to navigate these crazy, chaotic highways with a level of precision that we humans, well, we just can't match.
But it is so much more than just cars. I mean, picture this. Drones with LiDAR flying over a super dense jungle. The laser pulses can actually sneak through the leaves of the canopy, bounce off the forest floor, and map out ancient ruins that have been totally hidden from human eyes for centuries. How cool is that? So when you look at the big picture, LiDAR isn't just another sensor on a list of parts. It's really the primary sensory organ for this whole autonomous revolution. It's the piece of the puzzle that finally allows machines to truly perceive, to understand, and to interact with our physical world. And that really leaves us with a fascinating question to chew on. If we can give our creations the power to feel the geometry of the world with this kind of millimeter-perfect precision, what will they, and what will we, choose to build with that incredible power?